name is Shopify. And this is my final project for NLP on the classification of academic computer science papers into different subdomains. More specifically, the purpose of this project is to create a model using TensorFlow and Keras in Python that is able to accurately classify academic computer science papers into subcategories based only upon their title and abstract. The dataset I use is a collection of roughly 200,000 research papers that are hosted for free on archive.org, spelled with an X in the middle, as shown there by their logo. I hope to be able to classify these papers using titles and abstracts alone because this dataset doesn't contain the actual content of any of the papers. And that would be a lot to process and store anyways. So we'll only be working with the title and abstract. As you can see, there are actually two category columns. Of course, papers can speak on multiple subdomains with NCS, but I will be building my model to identify the singularly designated primary category, which would be written as, and all of the categories would be written as CS dot and then two letters, whether that be CV for computer vision or CS dot AI for artificial intelligence, as a couple of examples. So I will add a little disclaimer here that this data set was definitely made for multi-label classification, which is why there are the multiple category columns. But I still decided to go with single label classification just for a little bit of the added challenge and to see how it would work in a data set where there's just so much overlap between categories and the difference between one category or another being designated as the primary one could be even up to just a human judgment call. So then moving on to methodology, starting with a little data preparation. Other than some basic cleaning and dropping rows with insufficient content, as you can see on the bottom of my code there, I went ahead and just combined the title and abstract columns as I believe they provide essentially the same information that the model would need to use in determining the primary category. I mean, you can still distinguish them. I added the separator there, but they're going to be processed together. I combine them for that purpose. I also decided early on to filter the data set into only research articles within the top 20 most popular subdomains, like the subdomains with the most research papers written with them, just so I could be positive that there would be enough training data for all of the, all of the topics I would be labeling. So I realize you can't see all of those numbers, but here you go. The next decision I made was to do my train validation and test split in chronological order rather than making it entirely random, as you would in most other problems. In this way, the training and testing of my model more closely resemble how it would be realistically applied. Obviously, or at least for my implementation, I decided not to constantly stream new research articles into the model. So once it's built, it's built, it's done. It's out there classifying current research and the ever-changing vernacular and buzzwords and lingo that goes along with that. But of course, its training data will still only be composed of research papers that don't contain any of that lingo. So to to mimic, that sort of problem, that realistic issue that the model would have to deal with, I decided to split by time. if I decided to split randomly, my model would be able to sort of see into the future, like see future vernacular and buzzwords that it wouldn't actually have access to when applying the model to real research papers. This would, in effect, allow it to cheat a bit with its classifications by being able to see the vocabulary and proper classifications before deciding how they should be classified. So, again, I split by time instead of randomness. And from doing this, I would expect my testing to be more realistic and perhaps a little less accurate in training than it would be otherwise, with it not cheating. This would, of course, though, increase the overall generalizability of my model on test. If there were any topics developing more in recent years in particular, though, my model would certainly be worse at classifying those, especially, such as, what's on everyone's mind right now, artificial intelligence. Obviously, my model wouldn't be able to know the more modern and developing lingo and buzzwords that are being used now. But again, this just this would be the case if one tried to apply this methodology more realistically, like in the real world. So that's a good problem to have. That's what it should be doing, even if it results in me having a lower accuracy. Finally, onto the model itself. I first converted the combined titles and abstracts into a single vector that the model would be able to actually process. I achieved this by first applying text vectorization to convert them into tokens. Then I fed those tokens into an embedding layer before finally using global average pooling, to compress and flatten out the embeddings into one single vector. I then passed those vectors through this simple neural network. My only real goal with this architecture was to keep training times relatively low, while of course still ensuring that there are enough parameters to capture all of the information necessary. And of course, I included some regularization techniques like L2 and dropout just to ensure that I wasn't overfitting and I could generalize for test applications. And lastly, for the actual training, you can see at the bottom, you can see at the bottom here, I added class weighting to avoid bias towards the largest class. In fact, I might go back to show you. If you remember here, you can see CS.LG actually has over double the amount of research papers containing that topic than like any other topic, and some like way over double that. I believe that is logic, like logic in computer science, if you're curious. But anyways, so I implemented class weighting for my training just to punish the model for getting other classes wrong and discourage it from just playing it safe with its classifications and simply choosing CS.LG for the majority of its classifications because it would still get a decent percent right that way. But to avoid that, I added weighting to make sure that it's more willing to guess the non-LG labels. Then now onto the results. My final test accuracy was 0.69, meaning the model was able to correctly classify 69% of research papers into the correct primary category. While far from perfect, I believe this performance appropriately addresses my problem statement. The model I developed is able to classify academic computer science papers into subcategories based only upon their title and abstract. That is, it is able to perform this task in a significantly more accurate way then randomly assorting these papers into categories, or even putting them all into cs.lg, for instance. I will admit, however, that I expected this model to perform about 10 to maybe even 20% higher on tests than it initially did. Um, Perhaps I was a bit naive, though, about um, distinguishing a primary subcategory from papers all speaking on the same subject, computer science, and all of them, or at least the vast majority of them, containing multiple of these subcategories within the papers, and just having one be designated as the primary one. Sometimes that's, as I spoke on earlier, sometimes the difference between one or the other being designated as the primary really just comes down to the human judgment call. Um, if I were to approach this problem again, I believe a significantly more complex model and general methodology would be required to reach the test accuracy that I initially expected if I were to maintain my methodology of single label classification. Obviously, this data set is curated for multi-label classification, but I still think it would be interesting um, to try to reach for higher and higher test accuracies sticking to single label. I think that um, just to find what's, that's more complex of a task in this case. Um, and I also just wanted to quickly point out that my model does, in fact, underperform, or at least appears to, on more recently developing subject areas. As I mentioned before, artificial intelligence. As you can see on my per class F1 chart on the left here, CS.ai there's roughly tied, but I think it has the lowest F1, um, which, as I said, when I'm splitting by time is pretty much expected. So finally, just to end it off with some pros and cons of my implementation. For pros, I believe my model appropriately addresses the problem statement, mimics realistic chronological applications, and trains rather efficiently. For cons, it receives a relatively low test accuracy, at least compared to what I initially would think the test accuracy should be for a single label classification problem. But it makes sense considering that this data set is better suited for multi-label classification, um, meaning that there's just a lot of overlap among topics. And of course, again, my model doesn't perform as well at classifying more recently developing topics, such as artificial intelligence. Still, while not every part of this project turned out perhaps as I might have initially thought it would, I do believe I was successful in developing a model that can successfully classify academic computer science papers into their correct subdomains. Thank you.